So back in section 7-3, we talked about triangle similarity, which meant that we could have two triangles that were similar, meaning that their angles are congruent and that all of their sides are proportional. Remember, this means that they are not exactly congruent. That means that their side lengths don't have to equal each other. They just have to be proportional. So when we have triangle similarity, we can have three different kinds of similarity to prove that the triangles are similar. We can have angle, angle, side, 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 or side, angle, side. So when we have angle, angle similarity, that means that we have two angles that are congruent to each other. So in this picture, we have the angle C and angle F are congruent. And then we have that angle A and angle D are congruent. If we have two angles that are congruent in the triangles, that means that the third angle has to be congruent and that the triangles are similar. So that's how we know that we have angle, angle similarity. We also have side, side, side similarity, where if the three sides are proportional to each other, then the triangles are similar. So using our similarity statements, we need that AB needs to be proportional to DE, BC needs to be proportional to EF, so BC and EF, and that AC and DF are proportional. Okay, so that means if we look at 15 divided by 18, this ratio should be the same for all of the sides that we compare. So if that is true, then we have side, side, side similarity. The last one that we need to talk about is side angle side similarity, where if we have two sides of the triangle that are proportional and an included angle, remember that means the angle that is in between the sides that we're talking about, okay, then the triangles are similar. So the sides are proportional and their included angle, that angle between them, is congruent. It's the same. Okay, so those are our three different options. So down here looking at number 1, we need to explain how we know that the triangles are similar and write a similarity statement. Well, if we look at our triangles in here, we've got angles that we have measures for. So I see here that this angle measure is the same as this angle measure, and this angle measure might be the same as another angle measure. Do we remember that all of the angles of a triangle need to add up to 180? So if we want to find what this missing angle is, we subtract these two numbers from 180. So we have that 180 minus 92, because that's its angle, minus 49 gives us 39. So that means that this remaining angle is 39. So these angles are congruent, which means if I have two angles in the triangles that are congruent, then the triangles are similar. So the two triangles are similar by angle, angle similarity. At least two angles are congruent. We also need to write the similarity statement. So we need that triangle QRS is similar to triangle TUV. See how this angle Q is the same as angle T, and they are both the first ones in the similarity statement? and S and V were the same, so they're the last angles in the similarity statement. Okay? So number 1, the two triangles are similar by angle-angle similarity, and this is their similarity statement. All right? Number 2, this is something we talked about a little bit, and we keep having to pull it deep from within our brains. So in number 2, we're comparing some side measures. We don't know anything about GH and KL, but there is something happening in here with J. We have that these angles, these are vertical angles. And if you think way back to chapter 3, unit 3, vertical angles are always congruent. So that means that those angles are the same measure, whatever that measure is. Okay? So we also need to take a look and see for sure that we have proportional sides. Because if we have proportional sides, we will have side angle side similarity, where HJ is proportional to LJ, the angle J is congruent to itself, and it's the included angle, and that GJ and KJ are similar. So if we want to double check that to make sure that they are proportional, we want to compare our sides. So I'm going to compare these to these. Okay? And to check that, we can set up a proportion and cross multiply. When we do this, we get that 18 times 24 is 432, and 27 times 16 is also 432. Is 432 equal to 432? I think so. So that makes this a true statement. So these are proportional, the angles are congruent, we have side angle side similarity. So the two triangles are similar by side angle side similarity. And don't forget, we need to write the similarity statement. So we need that triangle HJG, H is going to be similar to LJK. See how I lined up the pink sides together? So I went from the H first to the J to the G. Also, again, the pink side, the L to the J to the K. All right. Now, we're going to verify that triangle ABC is similar to triangle MNP. To do that, we need to check the proportions. Do we see that we don't have any angle measures in here? If we don't have any angle measures in here, we can't talk about angle-angle similarity. We don't have any angles. We can't talk about side angle side similarity because we don't have any angles. So we need to be talking about side similarity. So we need to compare the ratios of all the sides. This is where the similarity statement is really important. Okay? So AB are the first two letters here. So I'm going to label the AB side as my pink side. MN are the first two letters in this other triangle. So they also need to be the pink side. BC is the second one. So we're going to make those yellow. NP is the second one, so we're going to make those yellow. Now, we're going to label our last sides as our blue sides because they're the leftover ones. So, to check these, we want to look at the ratios and compare them. So, I'm going to compare my pink side to my pink side. So, I need to compare 12 to 15. Then I need to compare my yellow sides, 8 to 10. And then finally my blue side, 12 to 15. So These were my pink sides, my yellow sides, and then my blue sides. Now, to see if all these ratios are the same, I'm going to plug them in my calculator. Okay, remember fractions are division. So 12 divided by 15, I get 0.8. 8 divided by 10, 0.8. 12 divided by 15, 0.8. So these are all the same. That means that the triangles are proportional by side, side, side. So they are similar by side, side, side similarity. Okay, so now I'm going to go ahead and we're going to flip to the back side and take a look at that. Okay, on the back, okay, we're going to look at the same thing. We're still talking about angle, angle similarity, side, side, side similarity, side angle, side similarity. Okay, we need to explain why the triangles are similar, and then we need to find the length. So, looking at what we have going on right here, this looks kind of similar to something on the back side. We've got these two triangles that are kind of tied together. Okay, so also again from the other side, way back from chapter 3, we have vertical angles. Okay, and they are always congruent. Okay, so we have side angle side similarity going on here, where we're going to look at those two sides and those two sides. We're going to believe that they're proportional right now, and we know that we've got this vertical angle. Okay, so these are similar by side angle side similarity. Okay, so let's go ahead and figure out what is my similarity ratio. What is it that makes me go from this small triangle to this big triangle? Because they're similar, so that ratio has to be used every single time to get from the lengths of these sides to the lengths of these sides. So our similarity ratio is going to be 8 to 12. 8 to 12, last time I checked, I believe that reduces to 2/3. So this is going to be our golden ticket to figure out what is GK. Okay, so let's set up a cross product. 2/3 times x over 11. We have that 3x is equal to 22 divided by 3. GK is equal to 7.3 repeating, or 7 1/3. Now, if this similarity ratio makes no sense to you, I'm going to do it a little bit different here on number 5, okay? Where we're not going to use the similarity ratio at all. But that's what's going on up here if you want to choose to follow these steps that they're showing you on the worksheet, okay? So, looking at these triangles, again, we need to explain why the triangles are similar. So, we've got the big triangle and the small triangle. We've got a side that is part of another side. And then we have some sides that are sitting together. And then, oh, look, what do you know? We've got this mark here that tells me that those angles are congruent. So I've got side, angle, and a side. So these are similar by side, angle, side similarity. So we are being asked to find US. Well, I know what UV is, and UV is part of US. We just don't know what this little guy is right here. What do we always label the thing that we don't know what it is? X. We're going to give it a variable. Okay? To get the whole thing, US is going to be 26 plus whatever this little guy is. Okay? So let's go ahead and set up a proportion now that we know how to represent how big US is. Okay? So let's compare. Let's go big over small this time. Okay? Big triangle over small triangle. Okay? My big pink side is 42. My small pink side is 28. My big blue side, remember the whole thing, US, is 26 plus X all over my small one, which is UV, which is just the 26. Okay, let's go ahead and cross multiply. We have 42 times 26, which is 1,092. And 28 times this whole thing. So I need 28 times 26 plus X. 28 times 26 is 728 plus 28X. I'm going to subtract 728 from 1,092. We get 370 is equal to 28X divided by 28. I messed something up, guys. It should be 364. I'm sorry. 364 divided by 28. X is 13. We're not being asked to find X though. We're being asked to find US. Remember, US is equal to 26 plus X. X is 13, so 26 plus 13. So US is 39. All right. Hopefully this helps you guys. Let me know if you have any questions.